Alright, I hope everybody's having a good day and welcome to some more fun with math. In this video I am going to cover two topics that have a lot to do with each other. One fairly easy and one a lot more complicated. So first and foremost, I'm going to look at what's called the square root method. Now, the square root method is a method used to solve quadratic equations as long as a special set of circumstances arises. And that circumstance is that you have a quadratic equation where the only variable term you have is ax squared. That beyond ax squared, anything else that may arise is just simply a constant, meaning your bx term does not exist in the problem. As long as that's the case, then you can use the method which is called using the square root method. That method is simple. You have to isolate your squared term, so get it all by itself, and then you simply take the square root of both sides. Now, as soon as you do that, you will automatically be generating two solutions, one positive, one negative. So what you have to remember here is that when we take the square root in this circumstance, meaning dealing with a quadratic equation, then your square root is going to have the positive and negative response as the solution. So I wanted to look at two different types of problems that you could potentially see, both of which can be solved using the square root method. So the first one is 3x squared equals 21. So let's go ahead and look at that. So I am going to start with 3x squared equals 21. So with this, what you need to notice or recognize is that in this problem, I only have, so here we only have ax squared and the c terms. Because of that, it means that we can go ahead and use the square root method. So the square root method says we have to isolate the square term. So that means I need to divide both sides by 3. This is going to give me that x squared is equal to 7. Once I do that, I have to take the square root of both sides. So I'm going to go ahead and do that. So I have to take the square root of my x squared side, which means the square root of my 7 side. Once I do that, the square root of x squared gives me x, and then because I'm taking the square root of the other side, I have to include plus or minus, and then I've got the square root of 7. Now, at this part, what you really want to make sure that you do is you want to make sure that you simplify the radical completely. It has to be as small as humanly possible. Well, if you look at the square root of 7, there is nothing else I can do to it. Therefore, my solutions here would be that x equals the square root of 7 and x equals negative square roots of 7. And this would be the result that we were looking for. Okay. Now, with that, I said we had another version. And so notice here I have the version that says I have a minus 2 squared is equal to negative 40. Well, what's important to note about this is that I actually have a square term and a constant without having the middle term. Now, some students or a lot of students will say, well, wait a second, don't I square this term out? And the answer is no, because you're just going to end up unsquaring it and factoring it down in the end. Instead, what you want to do is you want to leave it alone. And what you want to recognize here is that this represents your squared term, and this represents your constant. Because you have a squared term and a constant without the middle term, it means that you can go ahead and use the square root method. So you're going to take the square root of both sides, so this is going to become a minus 2 is equal to, taking the square root of both sides says you have to do plus or minus, and this becomes the square root of negative 40. Now just like before, you need to reduce your radical as far as it can go before you do anything else. So we have to acknowledge that we have this negative under the radical and we need to pull it out. The negative is going to be pulled out as an I, which follows your complex number rules. Therefore, this says you have a minus 2 is equal to plus or minus I square roots of 40. Now when I'm looking at 40, I know it can reduce. So when I look at 40, one thing that I see is I have 4 and 10. I know 4 can reduce to 2 and 2, which this right here gives me a group of 2 that I can pull out. Since I'm dealing with an index of 2, since there's nothing written there, I need a group of 2. The only thing 10 reduces is down to is 2 and 5, which is not going to help me any, so I can leave it as 10. This means I actually have plus or minus, and then I have 2 I square roots of 10. Now the very last thing that happens here is I still had this a minus 2 left. So because of that, I have to add 2 to both sides. So I end up with a being 2 plus or minus 2 square roots of 10 I. Now because of complex rules, this should be in standard form of a complex number. So your complex rules should remind you that that should be in the form a plus or minus bi. So when you look at this, it is, therefore there's nothing else that I can do. Thus, I have completely finished and reduced as far as I can go. Okay. Now with this, I can write my solution using the plus or minus, or I can write them separately, saying that a is equal to 2 plus 2 square roots of 10 I, or I can write it by saying a is equal to 2 minus 2 square roots of 10 I. Either one is going to give you the same result. Therefore, you have done everything you need to do. Okay? So those are 2 examples of solving a quadratic using the square root method. Now the reason we looked at that first has to do with the second method, which is the complete the square method. Now completing the square method is a method that's used because it will force an equation to fit the square root format. So it's going to force your trinomial to take on a form that will match the square root method, which allows you to go from completing the square to the square root method to solve. Completing the square says you first need to write your equation so that all the x terms are on one side and all the constants on the other. You want to make sure that the coefficient on your squared term is a 1. So if that is a value that's anything other than 1, then you need to divide it away, which then would most likely mean you're working with fractions. Once you've determined that you have everything in the right form, then you have to do what's called the completing the square step. So completing the square step is this third step here, which says you're going to take half the coefficient of the b term, square it, and add it back to both sides. You're then going to factor your left side down into your square root method form and finish out the problem by taking the square root of both sides. Now, I highly suggest to all students that you only complete the square if you're asked. So what I'm going to do is show you a couple examples on how to actually work this through. So here I have solve by completing the square. We have x squared plus 7 equals negative 8x minus 8. So the first thing that I have to do is I need to move my x terms, so my 8x, over to the other side, and I have to move my constant terms over to its other side. Because my 7 is positive, to move it says I have to subtract. Because my 8x is negative, to move it says I have to add. So this is going to become x squared plus 8x is equal to negative 8 minus 7, which is a negative 15. Now that I have it set, I've got my x terms on one side, my constants on the other. I'm going to set up the square root. When I do completing the square, I like to write my equation, x squared plus 8x, and input a space. I then have the minus 15, and I'm going to input that same space, because whatever I do to one side of an equation, I have to do to the other. Once I get it all set, I have to do what's called complete the square step. So complete the square step is as follows. I have to do b divided by 2 squared. So when I do the complete the square step, I like to do these 4 steps individually, because they are going to make the rest of the completing the square fairly simple. So first and foremost, b comes from the x term. So in this case, I have 8 over 2, and you want to pay close attention to the sign. The sign comes with, so this 8 is positive, and then I have to square it. Now this is real important. Don't jump ahead. 8 over 2 is going to give me a positive 4, square it, and when I square that I get 16. Now, this is why I said don't jump ahead. I now have everything I need. 16 is going to be the term that goes right here and that goes right here. So that is what you add to both sides. So I'm going to have x squared plus 8x plus 16 is equal to negative 15 plus 16. Now, here's the reason why I like to write all of these out. This side here has to become a factored term. So we're going to have something squared equals negative 15 plus 16. The variable that I'm working with is an x, so I have to be able to fill in the rest. Well, that is where this part comes from. The plus 4 is the piece that goes in right down here. That's why the sign is so important, because this becomes plus 4. So when you write out this complete the square step, as long as you do all these steps individually, what happens is you've already done the hard part. And so now you just simply have to finish it. So this is going to be x plus 4 squared is equal to negative 1. Take the square root of both sides, and you have x plus 4 is equal to plus or minus the square root of negative 1. Positive 1. Take the square root of 1 and you're left with x plus 4 is equal to plus or minus 1. Subtract 4 and you get that x is equal to negative 4 plus or minus 1. And you actually have to do the math. So here you're going to have that x is equal to negative 4 plus 1. Negative 4 plus 1 is a negative 3. And you're going to have that x is equal to negative 4 minus 1, which gives you a negative 5. Therefore, if we look at our solutions, my solution says that x is equal to negative 3 and negative 5. And this is the result from completing the square. Alright, now that was a lot. So, let's look at another one. Actually, I am going to save the fraction one for the end. So let's look at this one. So I have x squared plus 6x plus 13. So the first thing to note is that I am not in the proper form. I have to take this plus 13 and I have to move it. Because it is positive to move it says I have to subtract. Therefore, this leaves me with x squared plus 6x is equal to negative 13. Now that I'm in the proper form, I'm going to set myself up. This is x squared plus 6x, give me a space, is equal to negative 13, give me a space. Again, I have to do the complete the square step. Which says I'm going to do b divided by 2 and square it. Well, in this case, my b is a positive 6, so this is going to be positive 6 over 2 and squared. 6 over 2 reduces to a positive 3 and squared, which gives me 9. So again, just like before, I'm going to take this 9, and it comes up onto this side and up onto that side. And so here I've got x squared plus a 6x plus 9 is equal to negative 13 plus 9. I need to set up my factored term. My term, their variable is x, and so now I need to set up the rest. Setting up the rest is fairly simple. We're going to take this plus 3 piece and we are going to put that down there. Because the 3 is positive, this becomes plus 3. So I actually have x plus 3 squared is equal to a negative 4. Take the square root of both sides. X plus 3 is equal to plus or minus the square root of negative 4. I need to pull this negative out as an I term. So x plus 3 is equal to plus or minus I square roots of 4. We know square root of 4 is 2. So this is the same as x plus 3 equals plus or minus 2i. Move the 3 over. X is equal to negative 3 plus or minus 2i. Now this is standard form, so I'm good to go. It can either be left in this form or it can be written as x equals negative 3 plus 2i or negative 3 minus 2i. So you either write it with the plus minus or you separate it out. Okay. Let's look at another one. Here I have x squared equals 22 plus 10x. I'm going to take this 10x and I'm going to move it. It is positive, so to move it says I have to subtract. I need to set myself up. This is x squared minus 10x. Give myself a space. Is equal to 22. Give myself a space. Then I need to set up my middle term. b over 2 squared. My b term in this case is a negative 10. So this is going to be negative 10 over 2 and squared. Negative 10 over 2 is going to give you a negative 5 squared. And 5 squared is 25. Now that I have set up, my 25 is going to come up to this one and up to this one, which means the negative 5 is going to move. So here I've got x squared minus 10x plus 25 is equal to 22 plus 25. I need to set up my square root. My variable is an x, and so now I need to do the other. I'm going to take this negative 5 and I'm going to pull it straight down here. Because that 5 was negative, it's going to carry through. So this is going to end up being x minus 5 squared equals 22 plus 25, which is 47. Take the square root of both sides and we have x minus 5 is equal to plus or minus the square root of 47. 47 is not going to reduce any, so it can stay as is. Means the only thing I have to do is move that 5. X is equal to 5 plus or minus the square root of 47. Remember, you can either write solutions with the plus or minus, or you write them separately. So x is 5 plus the square root of 47, and x is 5 minus the square root of 47. Okay. Now for the one that I skipped. I left this one for last on purpose because what I want you to notice is that the other 3 examples that I did all had 3 different types of solutions. But all 3 of those examples, my x squared term had a coefficient of 1. Now we just looked at what happens if you boil down to having a whole number answer. We looked at what happens when you boil down to imaginary and what happens when you boil all the way down to still having a radical. The one concept we haven't looked at yet is this concept here, which is what happens if you have a coefficient greater than 1. The rule says to complete the square, the x squared term must have a coefficient of 1. If not, then you must divide it out. In other words, you have to force it to happen. So let's go ahead and do just that. So I have this 3x squared minus 5x plus 9. So 3x squared minus 5x plus 9 equals 0. And I'm going to divide the whole thing by 3. My first term here is going to become an x squared. My middle term becomes negative 5/3 x. And my constant becomes plus 3 equals 0. I now have to take my 3, so this part here, and move it. It is positive, so I have to subtract to make it negative, thus giving myself x squared minus 5/3 x is equal to a negative 3. In this case, my complete the square step is going to look a little bit differently. I know that I have to do b divided by 2 and square it. But instead of dividing by 2, I can also simply do b times 1/2 and square it. Now the reason why I would consider using this method is strictly because my b term is a fraction. It's a lot easier to look at fractions when you're multiplying them together than to look at fractions when you're dividing them out. So this in itself is going to become negative 5/3 times 1/2 and square it. Multiply straight across the top. You're going to get negative 5/6, and you're going to square it. You got to square the top and square the bottom, so this is going to become 25/36. So now, just like before, I have this term here, which is going to come up to the top of both sides, thus giving me x squared minus 5/3 x plus 25/36 is equal to negative 3 plus 25/36. I still have to set up my term. So my variable is still an x squared is equal to that negative 3 plus 25/36. And just like before, this fraction term is still going to be the term that comes down here. So I have x minus 5/6 squared is equal to negative 3 plus 25/36. Now, I must follow all fraction rules. Combining fraction means I have to have a common denominator. So let's go ahead and look at what we have here. We have negative 3 plus 25/36. One of the things that we have to remember is that any whole number is the same as that number over 1. So I need to find my least common multiple, which in this case is going to be 36. So I have to look at how do I turn 1 into 36? Well, I multiply by 36. So this is going to be negative 3 times 36 all over 36 plus 25 over 36. When I look at that, negative 3 times 36 is going to be negative 108 plus my 25. The whole thing is over 36. Because remember, with your fraction rules, when adding or subtracting, your denominator has to stay the same and you add or subtract across the numerator. So now I have 108, negative 108, plus 25 is going to give me negative 83 over 36. So I have to put that back together with what I already have. So I had x minus 5 over 6 squared is equal to my negative 83 over 36. I have to take the square root of both sides, so this becomes x minus 5 over 6 is equal to plus or minus the square root of negative 83 over 36. First and foremost, my negative has to pull out as an I. So this is x minus my 5/6 equals plus or minus I square root of 83 over 36. I now have to reduce by using your radical rules. Those rules say in order to reduce this through division, I have to use the division rule. So, if I were to take this, say, all the way back up, I have x minus my 5 over 6 is equal to plus or minus I, and the division rule says if it's together under one radical, it can be separated. So this can become the square root of 83 over the square root of 36. Well, we know the square root of 36 will reduce. So this becomes x minus 5 over 6 plus or is equal to plus or minus I square roots of 83 over 6. Here's your hint. Whatever you had in the denominator on the one side when you created your perfect square factor, you should end up with the same denominator on the other. Okay. In this case, there is nothing else to reduce but to move this one over. So I end up with x is equal to 5 over 6 plus or minus the square root of 83 over 6 I off the end. And then just like all the others, you can write them separate. So x is equal to 5 over 6 plus the square root of 83 over 6 I and 5 over 6 minus the square root of 83 over 6 I. Okay. And so that is everything that you need to know about solving quadratics using the square root method or solving quadratics by completing the square. Now that's a lot of information thrown at you, so please make sure that if you do have any questions over these examples or over my method approach, that you please reach out and ask. Otherwise, remember, math is bananas, and this is one such example. So please keep smiling, ask tons and tons of questions, be sure to have fun with everything you're doing, and remember to relax. And as always, I'll see you next time.